Section 3.5 is about parallel lines and triangles. So the first theorem is the triangle angle sum theorem. And what that is saying is that the sum of the measures of the angles of a triangle is 180. So in other words, all three angles of a triangle will add to 180. The second postulate is that just letting you know that if I have one point that is not on a line, you can only have exactly one line that is parallel to the given line. And we will do more with this in section 3.6 because you will actually make a construction of those two parallel lines. So let's take a look at some examples. This first example is asking you if I have two angles in a triangle that are 53 and 68, what is the measurement of the third? So if I were to draw this out, my triangle would look like this. You could just do some mental math and figure it out. So I could add 68 and 53 if I wanted to, and then I know that all three of them have to add to 180, so I could subtract it from 180 and get 59. You can go that route, or you could also set up an equation. So I know all three angles have to add to 180, so I could do 53 plus 68 plus x equals 180. I could combine my like terms and still get 121, and then subtract still and get 59. It is your choice which way you would like to go in order to solve that. Now you're going to pause the video and try the next one. Now in the next question, we have a different kind in terms of what they give you. Notice that they're not just all angle measurements, they give you a couple of expressions. So in this case, you would still have to write an equation in order to solve. So I would need to add all three angles. So I would want to do 7u plus 48 plus u plus 44 and set it equal to 180. Then I would just use my algebra skills to solve. So I would combine like terms, which would become 8u, and combine 48 and 44 and get 92. Then I would subtract 92 from the other side, and then I would divide by 8. So your answer should be u equaling 11. So even though it looks different, you're still going to use that theorem where all three angles have to add to equal to 180. Okay, the other kind of theorem that we talk about is going to involve exterior angles. And so an exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side. Then you're going to have two non-adjacent interior angles, and those are called your remote interior. So notice here, my exterior angle would be on the outside of the triangle, and then the remote interior angles are the ones that are opposite of those and then furthest away on the inside. So in this triangle here would be my exterior, these would be my remote interior, here would be my exterior, this would be my remote interior. So just making sure you're furthest away. So the reason we talk about that is because there's a theorem called the triangle exterior angle theorem that allows you to find some of those angles. And what that says is that the exterior angle will always equal the sum of the two remote interior angles. So if I add angle 2 and 3, that would give me what angle 1 is. So we're going to put that to use down here at the bottom. So here is my first example. It asks me to find angle 1, and from that I'm just going to add 80 and 18, so I would get 98. So then I would also have the measure of angle 2, but notice that in this case for angle 2 I have remote interior, so 124 is my total. So if I set up an equation, it would look like this, where I add 59 and x, and then I would need to subtract 59 in order to find that missing interior angle. Now you're going to be completing two IXLs, and you want to make sure that both of them have problems where they're just normal degree angles, and then you also have some that involve expressions. So remember to use this format if it doesn't have just the regular angle measurements in there. Okay, so you can now go ahead and start on the two IXLs. There's one more example I wanted to show that got cut off on this note-taking guide. So notice in this example that there are no angle measurements here, but I'm still going to know that this exterior angle will be equal to the sum of these two. So that's how I set up my equation. this is my exterior angle, and I'm going to set it equal to the sum of those two. So I added this angle with that angle over there. Now I'm just going to solve. So I combined my like terms, I minused this 1c over, and then I subtracted 11 to the other side, and I got c equaling 34. So I just wanted to make sure you had an example to go off of, because not all of the problems on the IXLs are involving the degree measurements. Some do involve these algebraic expressions.